Hello everyone, how are you doing? This video is going to discuss the limit of the sequences. If you remember in calculus 1, whenever we try to describe the limit, we pick the point C and we said we're going to take a neighborhood around point C. And for every one of these points in the neighborhood, I'm going to pick an arbitrary point. That arbitrary point is X. And for every one of these X, you must have a Y value, except at the point C. Therefore, if all this number that you are reaching from the right and the number you are reaching from the left, they reach one specific number. That one specific number is called a limit. But remember, every one of these X value must have a Y value. Therefore, you cannot have any discontinuity between them. Therefore, if I pick up the X value to the right, X minus C must be a positive number. And that number, I'm going to call it, must become less than delta, and delta is a difference between the X and a C, and that's called a delta. But what happens if the X in here, therefore C minus X must be less than a delta. But if I put this one inside the absolute value, I can write as one simple equation and call this one less than delta, but delta must be a number greater than 0. Then if this situation satisfied on the x-axis, therefore for every one of these x value you have a y value, and that's called f of x. But if you take the f of x and subtract the limit, that must also come out with a tiny numbers. Therefore we said, and somebody said, why you put absolute value? Because f of x on the bottom, the distance is going to be L minus f of x, because the L is a larger y value. Therefore, this said f of x minus L must be less than an epsilon. And that was the delta epsilon definition of the limit in calculus 1. When you talk about the sequence, and you talk about a sub n equal to some sequence, I don't know what it is, and I just made an example of explicit form. You must have a number such as m. That number must be a positive number. That m could be a million, could be trillion, could be whatever that number is. That a sub n minus L must be less than epsilon. Therefore, instead of a f of x, you get a sub n minus L. But what is the condition? That n, if m is a trillion, that m could become trillion and one. Then, if the n is greater than m, and there is such a condition exist, they said the limit of a sequence does exist. And they said the sequence converges. If the limit of a sequence does not exist, therefore they said is diverges. Then you also can use graphically, and if you go right here and put y, I need to put the sequence right here, and if I put a sequence right here and say my sequence is 1 divided by n squared, that's my explicit form. Remember, n cannot be a 0, therefore I start from 1, and 1 over 1 is going to become 1, therefore the lowest value is going to be 1. That is said what? Use of n minimum. Here you can put 2 or 3 or 4 or 5, whatever it is, that's the first term. Somebody said, why they put even that use of n minimum? Because they want to let you know if you have a sequence and the sequence is going up, 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 up and reach a peak, but it go to infinity, it's going to come down. you can easily cut the first 100 term, because what is important is close to infinity. You cut the first 100 term and see what happened to those terms at the end. And if I go back right here and graph it, that's all I see. But what is the next one? See, the next one is 1/4, 1/11, 0.625. Therefore, you need to go to your y value and say, I don't need all this x value, because n is always a positive number. And my x, I don't need a -1. But in here, I maybe go to 1.5 with a scale of 0.1. See, right now, you got your 1. And see, you got the 0.25, and that's 1 over when it's a 3, 3 1 over a 9, and so on and so on and so on and so on and so on. And you see, as the n approaches, that a sub n minus the limit is always going to become a what? An epsilon, and maybe that one going to converge. Means the last limit, the last term is going to become some finite number. Is not going to become an undefined quantity. Therefore, somebody said, how do you find a limit of a sequence like 2n over n plus 1? I said, I don't know. I want to know what is my limit of a sub n as n approaches 1. Well, that's very easy. 2 over 2 is 1. And you do use substitution. And whenever you do substitution, therefore you know you're going to have a what? You're going to have an explicit number. And you're going to have a finite number. Therefore, your limit approaches a specific number. Okay, but sometimes they said, what is the limit of a sub n as n approaches infinity? Oh, that become infinity over infinity. I'm going to apply L'Hopital rules. Nope, L'Hopital rules are for function. But if you go to your graphing calculator and you press mode and you press function and you only graph the line of y equal to x, that's what you're going to see right there. And that's become the line of y equal to x. What do you know about the line of y equal to x? It is continuous. Somebody said, what is continuous? Means after 0, they have 0.000000000. They're not going to leave any points off on the number line. Means your x can take any number from a number line. But somebody said, what happens if I put a sub n equal to n? I'm sorry. When n is 0, you have 0. When n is 1 is 1. When n is 2, you get 2. When n is 3, you get 3. When n is 4, you get 4. But what is the difference between these and y equal to x? Oh, y equal to x is any values. Any one of them is your y value. But the sequence you answer is only those integer number. Therefore, I'm going to say, okay, if I want to find the limit of any sequence, I'm going to find the limit of the function because they have same values at every integer point. Maybe n cannot be 0.5 or 1.5 or 1.7 or so, but I know n can be 1, 2, or 3. Therefore, when you have a sub n, you got to change it to f of x and say 2x over x plus 1. Then you take the limit of that one as x approaches infinity of 2x over x plus 1. Then you can say that's infinity over infinity. And what is the limit of x approaches infinity using L'Hopital rules is 2 over 1. And the limit is 2. Therefore, my number as x approaches infinity, I am approaching 2. Somebody said, what do you mean by that? Because if I go right here and plug into the function 2x divided by x plus 1, and in here I said, what is my y value when x is 1,000? When x is 5,000? When x is 10,000? See, the number never gonna get 2. Somebody said, why the number never get 2? Because whenever you graph that one, you graph what is it? You see right here, and you cannot put the left side because here n is negative. Here they call this one the least or the lowest upper bound. Somebody said, am I approaching 3? I said, yep. Am I approaching 4? Yep. Am I approaching 5? Yes. But among all the number greater than 2, 2 is the least. Therefore, this one called the least upper bound is equal to 2. Therefore, that's not the same as this one. When n is 1, you get exactly 1 at an integer point. But in here, you are approaching 2. You might not even ever get 2. Therefore, if I go to my table, see, I am approaching 2. Do I ever get 2? No. Therefore, if you want to find the limit of a sequence, you're going to change it to a function, and then you find the limit of the function. Therefore, the same thing you study as a function, what is the limit of x squared plus 2 times x plus 7 as x approaches 1? In here you said 1 plus 2 is 3, 1 plus 7 is 8, and that's 24. And we said in calculus 1, the limit of the product is the product of two limits. Therefore, when you 1 here is 3, when you put 1 in here is 8, and you get 24. Therefore, if you have a limit of a sub n as n approaches infinity, and you get L, and the limit of b sub n as n approaches infinity, you get k, then the limit of a sub n times b sub n, and remember these two index must be the same, approaches infinity is L times k. And what is the same thing if it's the sum of two limit of x squared plus the limit of 2x? When x approaches 1, x approaches 1. Do you see my index are the same? This is 1 plus 2 is 3. Therefore, or somebody say, can I put limit of x squared plus 2x, and when x become 1, that become a 3? I said, yes, the limit of the sum is the sum of the limit. Therefore, the limit of a sub n plus b sub n as n approaches infinity is the same as limit of a sub n approaches infinity plus the limit of b sub n as n approaches infinity, and that's nothing except L plus k. You can do the same thing with the negative. You can do the same thing with the division. Therefore, if you have a limit of a sub n approaches infinity over the limit of b sub n as n approaches infinity, you can see the limit n approaches infinity of a sub n over b sub n, and it's L over a k. But the condition for division is that limit cannot be a 0. Therefore, that k cannot be a 0. That's something you should know. Okay. Then also, we talked about how do we find the limit. If you remember in calculus 1, we said, what is the limit of sine of x over x? as the limit of x approaches infinity. Well, here you said you have infinity, but the signs always go from -1 to 1. When I'm approaching infinity, is -1 to 1. I don't have a specific number. I know the value is going to land between these two numbers. Somebody said, oh, I know eventually it's going to be a number, and some numbers over infinity is going to be a 0. Sir, you cannot do that, because that should become a finite number. Somebody said, what am I going to do? I said, you know sine of x is always between 1 and a -1. What do you need right here? Sine of x over x. Then what you do to this side, you do to this side, all three sides. You don't know what the limit of this one is when x approaches infinity, but I know the limit of that one when x approaches infinity because I have a fixed number on the top. Nothing wrong with that. That's not between -1 and 1. This is just a -1. And what is -1 over infinity? Is 0. But I don't know what the limit of sine of x over x is as x approaches infinity. But I know if I take the limit of that one as x approaches infinity, it becomes 1 over infinity. And that's the finite number. It's not between -1 and 1. And that's the 0. Can you give me a number which is less than or equal to 0 and greater than or equal to 0? That number is 0 itself. Therefore, you said the limit of the middle is 0. This is called squeeze theorem. Sometimes you have a sub n equal to -1, maybe 1 over, maybe let me put this one alternate, positive or negative, n factorial. And you're going to say, oh, and I want to know what happened to the limit of that one, what number I'm approaching in this case. And therefore I have to start thinking, if I want to find the limit of a sub n as n approaches infinity, what I have to do. Somebody said, okay, is equal to -1 to the power of infinity over infinity factorial. But remember, -1 to the power of infinity means -1 times -1 times -1 times -1 times -1. You got to keep going and keep going and keep going and keep going. And I have no clue. What is that limit right there? But if you remember something in college algebra gave you a polynomial function such as y equal to x squared. And they said how powerful this one is. They said when x is 0 is 0, when it's 1 is 1, when it's 2 is 4, when it's 3 is 9, when it's 4 is 16, and even when it's 10 is 100. That's how powerful it is. Because as whatever the x is, you're going to square it. But somebody said, is this one going to be more powerful than 2 to the power of x? I don't know. When x is 0 is 1. No, this is more powerful. When x is 1, this is 2. Oh, that's more powerful. But when x is 2, this, oh, they are the same. Oh, when x is 3, this is 8. No, polynomial is more powerful. But let's ignore, and when it's 4, it's 16. They are the same again. Therefore, if these two go to wrestling match, and they're gonna wrestle for 10 rounds, first round, this one gonna win. Second round, this one gonna win. Third round, they're gonna be tied. Fourth round, polynomial gonna win. Fifth round, they're gonna tie. But my goodness, when it's the fifth round, this is 25. Fifth round, this is 32. When it's sixth round, is 36. When it's sixth round, is 64. Seventh is a 49. Seventh round is 128. You know, after the fourth round, this function is going to beat polynomial in matter of a second. Up to fourth round. They switch. But somebody said, what happens if I have y equal to, n factorial? Let's talk about that one, but the factorial. I said, well, when n is 0, I get 1, because 0 factorial, it was, my mathematician chose to become 1. When it's 1 is 1. Therefore, see, if I put all these three, this one with this one with this one, exponential function gonna beat both of them. But in here, exponential and polynomial gonna be, exponential and factorial gonna be polynomial. But when I put 2 right here, I get 2. Oh, factorial is the loser. 3, factorial is the loser of all. 4, oh, 1 times 2 times 3 times 4 is 24. Oh, when it's 4, I think factorial gonna win. 5, 120. 6, 720. 7, you gotta multiply this one by 7. That's almost a 5,000. Then after n greater than or equal to 4, factorial is the winner of all wrestling match. It doesn't matter if you go wrestle with a polynomial or exponential. After polynomial, the second best is exponential, and the last is this one. Therefore, if I want to find the limit of that one, I'm going to compare this one with the exponential function, and I'm going to put 1 over 2 to the power of n. And because this one is a negative, and it's going to be less than or equal to negative 1 to the power of n, 1 over n factorial. And this one is going to become, somebody said, why? Because this number is a huge number, and this number is going to be less. Therefore, the one, the denominator is less and less and less, is going to become the bigger one. But this and this is going to be negative. But all these two is going to be less than the positive. But if I take the limit of that one as n approaches infinity, take the limit of that one and approaches infinity, that limit becomes 0, that limit becomes 0. What do you think the limit of that one is? The limit of that one is going to approach 0. This is called sandwich method. This is called a squeeze theorem. Therefore, sometimes you have to use a squeeze theorem to be able to find the limit of the sequences. Also, something else. Sometimes you have a sequence of negative 1 to the power of n of 1 over n squared. Okay. They said, what happens when n is 0? You cannot have 0. When n is 1, when n is 1, negative 1 to the power of 1 is negative 1. When n is 2, negative 1 to the power of 2 is positive 1/4. When n is 3, it becomes negative 1 over 9. When it is 4, that's even, become plus 1 over 16. Therefore, do you see positive, negative, positive, negative, positive, negative? Somebody said, if I take the absolute value means all of this is going to be positive. And it's going to be much larger than when it's alternate. And if the absolute value of a sub n converges, means if you take the limit of a sub n, n approaches infinity, if this converges, I will guarantee you that a sub n with the alternative sign is going to also converge. Therefore, if this one approaches 0, I bet you this one is going to approach 0 too. Therefore, this is very important to understand the squeeze theorem. Therefore, you understand the comparing with a function, and then you also understand that you can do the absolute value and how those things is going to be working. Okay, then somebody said, let's do some practice. I said, okay. Let's have something x of n, and what is the sequence? Is a set of numbers, and those numbers have some pattern. Okay. Therefore, I'm going to say that set include 5 plus negative 2 to the power of n. That's the implicit form. Does this converge or diverges? Well, I have to start thinking. Even if I change this one to a function, what happened? Well, let's talk about the sequence itself and look at the first few terms, and if we cannot decide, we need to find another way. What happened when n is 1? That becomes 3. What happened when n becomes 2? That's the even. That becomes 4. And that becomes a 9. What happens if n becomes 3? Remember, when it's 1 become, that's good. When n becomes 3, that becomes 5 minus 8 and negative 3. When n becomes 4, that becomes a positive number, 21. When n becomes 5, negative 2 to the power of 5 is a negative number, and 2 to the power of is negative 32. Negative 32 plus 5 is negative 27. Therefore, do you see you have 3, you have a 9, you have a negative 3, you have a 21, you have a negative 27. And what happened to that number? I bet you the next number is going to get bigger. The next number is going to be bigger, but one is the positive, one is a negative. Somebody said, how I am going to determine that? Well, in here, if you take the absolute value of these, the absolute value diverges, but this one is alternate between a negative and a positive. Let me do one more. When is what did I say? That's the n4 is a 21, and then what happened when n is 6? Negative 20, that become a negative 64 plus a 5, and that's make it a negative 59. Let me see, what did I do right here? I had 3, 9, negative 3, 21, negative 27, and then this become an even number, and negative 2 to the power of 6 is 64, so that's a 69. See, therefore it's alternate between a positive and a negative, positive and a negative, positive and a negative. Therefore, you know this one is not going to converge at all. Therefore, it is not, this one does not have a limit, because it's alternating between a positive and a negative. Therefore, sometimes you have a sequence is go from 3 to negative 5, 3 to negative 5, 3 to negative 5. These are not, you're never going to know what happened to it, and these are going to say they do not converge. But sometimes said, what happened if s of n, and my s of n is n over 1 plus minus a 2n? I said, I don't know anything about that when n goes to infinity, but I'm going to do when x goes to infinity of x over 1 minus 2x, and that become infinity over infinity. And when I apply L'Hopital rules, when I take the derivative of that one, it become x approaches infinity, I get negative 1/2. Therefore, I say, goodness, this one does converge. That is very important to know those. Also, I want you to understand one thing. There are certain sequences like h of n equal to n squared plus 3n minus a 1 over n cubed plus a 1. What happens when n is 1? You have 4 minus 1 is a 3 and over 2. What happens if n is 2? 4 and 6 is 10, 10 minus 1 is a 9. And 2 to the power of 3 is 9, 9 plus 1 is a 10. Oh, 2 to the power of 3 is 8, 8 plus 1 is a 9. What happens if n is 3? 9 plus 9 is 18, 18 minus 1 is a 17, 27, 28. What happens if n is 4? 16 and 12 is 28, minus 1, 27, and 4 cubed is 64, 65. Therefore, I'm going to scratch this one off and I say, can you give me a sequence and tell me what is this pattern? That pattern was driven from that one. Sometime giving you the sequence and asking you give me a sub n is not easy. You only can determine by some of them. Like if you have 1, 3, 5, 7, 9. Therefore, you see these are odd numbers. Therefore, this is A1 plus 2. This is A2 plus 2. This is A3 plus 2. This is A4 plus a 2. Therefore, you can find this one and say is 1 plus, let's talk about it. What is the difference? The difference is a 2. And what is your a sub 1? Your a sub 1 is 1. Then your a sub n is going to become 1. You add a sub 1 plus 2 times n. If a sub 1 is 1, and when n is 0, you get 1. When n is 1, you get 3. When n is 2, you get 5. When n is 3, you get 7. Therefore, you can find the explicit form of a sub n to become a1 plus a 2n. Therefore, easily you can find that one and say, okay, that's my explicit form. And somebody else said, would you give me something else about the sequence of having 2n plus 1 over 5n minus 1? Maybe a sub n is equal to 2n cubed plus 6n over 5n cubed minus 3n squared plus 7, and tell me if those functions are going to converge or those functions are going to diverge. Okay. Remember in college algebra we learned something, we call it horizontal asymptote. And sometime you said y equal to 1 over x. X cannot be 0. And also the graph as x approaches infinity, this approaches 0. Because remember, when x is 0, you start from infinity, and when this becomes infinity, approaches 0. Therefore, I am approaching the line of y equal to 0. Therefore, I am building a wall in front of my graph, and I said, you are bounded. You cannot pass this line. Therefore, this one is called bound. Bound sometimes is on the top. Bound sometimes is on the bottom. Bound sometimes is on the top and the bottom. Okay. What happens if the bound is on the top? Please pay attention. If this one becomes the line of y equal to 2, they call this one the smallest of the upper bound, or the least upper bound. If it's from the bottom, they call this one the highest of the lower bound. But if it's bounded from the top and the bottom, they just call it bounded. Okay. Then from today you have to know, if a function is bounded, the bound could be above, the bound could be below, or the bound could be above or bottom. If it's bounded, but it has either upper bound, or it has a lower bound, or it has an upper and lower if it's bounded. But the function has only one voice. Voice is going up, voice is going down, voice is going up. One voice means monotone. If it's monotone, somebody said, can I call this one increasing? No, that's not a function, that's a sequence. Don't call it increasing, call it non-decreasing. You gotta make a little bit difference between sequences and the function. This one is decreasing. Don't call it decreasing, call it non-increasing. If you have a sequence is bounded and monotone, I bet you is gonna converge. Therefore, you have to know that one. That's another condition for those things. Okay, let's talk about these. Let's say a sub n equal to 10n squared plus 3n plus 7 over 2n squared minus 6. I don't know if this sequence is bounded, but if I change it to a function, I might be able to apply L'Hopital rules and say, okay, I'm going to apply taking the limit as x approaches infinity of that function, and that becomes infinity over infinity. I'm going to do it one more time, and I'm going to say the derivative on the top is 20x plus 3, and the bottom is 4x. That's the gain infinity over infinity. I do L'Hopital rules again, and it's 20 over 4. That's the limit as x approaches infinity, and I said 5. That 5 is your bound. That 5 is your horizontal asymptote. Therefore, somehow the graph at y equal to 5 approaches that one. And somebody said, is that the upper bound or is that the lower bound? See, that's something I really don't know. Somebody said, how do you know? Put a number right here. Maybe x equal to 10 or x equal to 1 in this area. Therefore, you have 10 plus 3 plus 7, 1, 2 minus 6. If this number gets larger than 5, that's the lower bound. Therefore, this is 20. 20 over a negative 5 is a negative 4. Therefore, when n is 1, I have a negative 4. Therefore, I bet you this one is the upper bound. And somebody said, I don't believe you. You go to that function right here and say y equal to 10x squared plus 3x plus 7 divided by, open parenthesis, 2x squared minus 6. And I'm going to go to my window and make sure I have the 5. I'm going to have the 5 right here. And let me see what, oh, I did not put the upstairs in the parentheses. I'm going to put 10x squared plus 3x plus 7. And that should be a 7, and that should be a parenthesis. And I'm going to graph. See, oh, then this is your upper bound. Therefore, I'm talking about that sequence. Therefore, I know it's going to converge. But if you're going to find out, is this going to be an upper bound or that's going to be a lower bound? Let me help you, please. You want to know if it's an upper bound, lower bound? If it's an upper bound, it must be non-decreasing. And if it's a lower bound, if it's an upper bound, it had to be non-decreasing, means increasing. And if it's a lower bound, it had to be what? Increasing. Therefore, the slope of a tangent line here is 0. The slope of a tangent line right here is negative. You can go take the derivative right here and say this become, take the derivative. 20x plus 3 derivative of the top times the bottom minus derivative of the bottom times the top over bottom square. Therefore, you know the bottom is always going to be positive because of that one. Then, if I pick any numbers for x, like 8, 9, 10, 11, 12, let's make it 10. That's become 203 times 200 minus 6 is 196, and that's negative 40 times 10 is a negative 40. Therefore, you see that number is 10x squared plus 3n plus 7. That value is a huge number. Therefore, that number is going to be a negative number. Therefore, the slope of a tangent line is negative. Therefore, you do know this one is going to be decreasing, and that's going to become your lower bound. Therefore, you can see this one converges to number 5. Somebody said, what happens if I ace of n equal to 1 over n sine of n? Is this one is going to converge, or if this one is going to diverge? I don't know. But I know the sine of x is always less than 1 and greater than negative 1, between negative 1 and 1. But I do have an n here. I'm going to put the x in here, I'm going to put x in here, and I'm going to put x in here. I'm going to take the limit as x approaches infinity. That's become 0. I'm going to take the limit as x approaches infinity. I don't know what this one is, and I'm going to take the limit as x approaches infinity. Therefore, this becomes the limit of x approaches infinity of sine of x over x less than or equal to 0. And that limit is 0. Therefore, that sequence, well as n approaches infinity, is just get converge. And it converges to 0. Therefore, you have to start working on your sequences and see if your sequence is monotone, if it's bounded, then you can see that's converges. Then if it's not, you can find the limit using L'Hopital rules, and then you see what happened to the limit, then determine the converges, diverges, and many other methods that we explained, and that's how the sequence work. And hope you enjoyed this video.